All right, so for our mole conversions, what do we use them for? Well, we use them to change either moles to grams. Remember, we can't really measure moles, so we can convert it to grams so that we can actually measure it out. Or if we already have an amount of a compound, from grams to moles, okay? So we can go back and forth between grams and between moles pretty easily using the molar mass. Why do we need to do that? Well, in a balanced equation, we'll say chemical, because, okay, chemical equation, those coefficients, the coefficients, you guys can see that, okay, the coefficients are equal to the moles of that element or compound to create the reaction. And you guys are going to discover next week in our mole rockets how important having the correct number of moles really is. Okay? And you'll see how that changes the chemical reaction. Okay? And so what do I mean? Well, let's take a simple reaction like to make water, which you guys will actually do. This is the reaction you guys are going to do in your mole rockets next week. Okay? And so remember, these right here, these are our coefficients, right? Those are things that there's, we're talking a lot about that there's two of these molecules or one of those molecules. Really, and that makes it pretty easy and balancing, but in reality, what that coefficient tells me is the number of moles. Okay, and remember the number of moles is 602 hexillion molecules. So it's 2 times 602 hexillion. That's how many molecules have to go into this reaction. So when you read this reaction from now on, the way you should be reading it is this way. So this balanced equation, if we were to read this equation out in words, says that 2 moles, and we're going to shorten it moles to MOL probably from now on, of hydrogen and 1 mole, because if there's no number, it's 1, of oxygen molecules are needed, okay, to create 2 moles of water, okay? So if I was to read this equation in words, that's exactly what it says. I need 2 moles of hydrogen plus 1 mole of oxygen to create 2 moles of water. So it's not just about the number of molecules. It's actually each one of those, if you think about when we went on the FET, each one of those little pictures is a mole of that molecule or compound, okay? So these coefficients just don't represent the number of molecules, it's the number of moles, okay? So it's a much bigger number, and that would be really confusing to look at on a computer if it added 602 hexillion times 2. So that's why it does just one at a time, okay? And if we don't have, and without the correct number of moles, there would be no reaction. Or there would be an overreaction. So if I added too many moles, we'd have too big of a reaction. If we added too little moles, we'd have no reaction at all, okay? So it's really important that we understand that it doesn't just represent one molecule of compound, it's 1 mole or 602 hexillion of them, okay? Is really what those numbers represent. So we really need to be able to convert something to grams to know how much we need to mix to make things work, okay? So we use mole conversions to do that. So there are some steps to mole conversions, which you guys have kind of already learned. Remember when we did the conversions in the first semester from centimeters to meters, or maybe decimeters to meters, or grams to kilograms? Remember when we learned that? We're going to use that same process, but we're going to bring it back here in mole conversions. And we're going to use the mole and the molar mass instead, okay? So, steps to mole conversions. Okay. And some of these might seem a little redundant, but I will tell you, until you get better and better and do tons of them, use them for a while until you get really good at doing this, okay? All right, so the first step I teach is you're going to read the question, the whole question. And to make sure that you're reading the question and thinking about what the question says, there's a couple annotations I have you guys do within the question itself, okay? So you're going to box, means put a box around, the number, the units, and formula that the question gives you. And we're going to call this, just for short, we're going to call this the given. So this is the number, the units, and the formula that the question gives you. What does it make you start with, okay? The second annotation you're going to add is you're going to circle, okay, the units and formula that the question is asking for. And we're going to call that our want. What do we want? What do we want to find? What are we looking for? What do we need? Okay? So that's the first thing, is you're going to annotate your question. Okay? The second step is you're going to calculate the molar mass of the element or compound in the question. Okay? So the nice thing about these conversions is they're going to be asking about just one molecule or compound. So you're going to calculate 1 molar mass to do this, okay? Eventually, as we get farther in, you'll be calculating multiple molar masses, depending on what you need, okay? This time, just one at a time, okay? Then we're going to set up our formula, our conversion. You're going to write the given with units and formula, okay? This can be a fight for some students every year because they don't want to write it. But if you get in the habit now, as you get to our higher stoichiometry, as we're adding more than one compound, more than one molecule, more than one element, it helps you keep track of things, okay? So as you get into the habit of adding those units and the formula, it'll just be a habit as you keep going, okay? It doesn't take any more than 2 seconds. So just do it, okay? All right. Then the next step is you'll create our train tracks like we did last semester. I'll remind you what those look like. And then on the top of the train tracks, write the units and formula, okay, of your want, or what you circled. Very easy to see, right? Oh, I circled it. That's what I'm putting on top. Notice it doesn't say number, just says units and formula, okay? On the bottom of your train tracks, write the units and formula of the given, or what you boxed in your question, okay? Okay. The next step is to add the numbers from the molar mass. Last step, anything on top, you multiply by. Anything on the bottom, you divide by. Just like if you were multiplying two fractions together, right? And figuring out a decimal. You would always multiply the top numbers or the bottoms, and then when you get to the end, you divide, okay? So anything on the top, you're going to multiply by. Anything on the bottom, you divide by, okay? All right, we're going to go through a few examples, okay? Of going both ways. We're going to go grams to moles, moles to grams, okay? Questions so far? Okay. So one of the things I'm going to warn you about is you will also need, we're going to start this on our notes on the other page in just a minute. You will always add to your answer your units and your formula, okay? Without those two things, we don't really know what that number represents, okay? You can put 2.5, but what is it? 2.5 cubes, 2.5 pencils? I don't know, okay? So it's really important that you're going to put your units, okay? So this one, it's either grams or moles, and then your formula. What is it? What is it of? Is it of salt? Is it of sodium? Is it of magnesium? I don't know, okay? So it's really important that you add both of those things so that we know what we're talking about. As you're doing that, that keeps your mind clear as we go forward, as we start adding more steps, more things, okay? All right? All right. Okay. All right, so make a little note for yourself. Always add units and formula to answer. Okay? You should always know what units it in. Are we talking about grams, milliliters, liter? What are we talking about? And then what is the compound? Okay? So our first example. We're going to do moles to grams. That's our first one. So you'll have questions that look like this. How many grams of sodium are in 3 moles of sodium? Okay? So as you read it, this is when our annotation begins. So we're going to box our given, which means that's the number, units, and formula that it is giving us to start with. So notice it's telling us this is what we're starting with. So we're going to box that. There's my given. Okay? And we're going to circle what it wants us to find. So what it wants us to find in this one is grams of sodium. So that's our first thing. We're going to annotate our question. Okay? Second step, we're going to calculate the molar mass of sodium. Where can we find the molar mass of sodium? Where can we look? Periodic table. So when we look at the periodic table, sodium is 22.99. Okay? And I want to show you guys another thing about the unit. So we've been writing it this way, which is true. It can be written this way as well. And you must think of it this way, that there are 22.9 grams of sodium in 1 mole of sodium. Remember, whenever we're getting something off the periodic table, it's always just in 1 mole. Okay? If we need more than that, that's when we have to calculate the molar mass and do a conversion to find out how much it is. Okay, like we're doing now. All right. So our next step is we're going to write our given. So we're just going to copy this down. So 3 moles of sodium. That's our next step. We're going to create our train tracks. On the top of our train tracks, we're going to write the units and formula of what we circled or what we want. So I'm going to shorten it to grams of sodium. Notice I'm not writing a number. Then I'm going to write the units and formula of my given, which is over here in my box, moles of sodium. Now I'm going to add my numbers. You get your numbers from this molar mass right here. This is why I wrote it out this way. Even though it's written this way, it still is the same thing written this way. So then we're just going to plug in our numbers. The number goes with the grams. We're going to put 22.99. And the number that goes with moles, it's always in 1 mole. Okay? So remember, anything on top, what do we do with those numbers? Multiply them, and we divide by anything on the bottom. Divide by 1, does it do anything? No. So we're going to multiply these numbers together, and you should get, if you did it, 68.97 grams of sodium. Notice I added my units. How did I get that? Well, remember in math, X's, if they're on the top and bottom, can cancel, right? But here in chemistry, we don't really have X's, okay? We have units. Notice I have moles of sodium on the top and moles of sodium on the bottom. These will cancel out to just leave my grams. So that's how you know what you should have there. This is kind of a check for yourself. If you can't cancel those 2 units, you set it up wrong. Okay? It's just a check as we go forward. Okay? Questions so far? Okay. How about an example of how many grams of sodium chloride are in 1.5 moles of sodium chloride? Okay, so now we have a formula. All right. So I'm going to go ahead and box my given. What's my given in this question? 1.5. So we're going to box that. Moles. Notice I'm boxing the whole thing, right? What does it want me to figure out? What is my want here? What does it want us to know? Grams and of sodium chloride. I'm going to circle that whole thing, okay? Then I'm going to find my molar mass of sodium chloride. And I have 1 sodium, 22.99, plus 1 chlorine, 35.45. If you did that, it would come out to 58.44 grams per mole. 1 mole, okay? Then we're going to go ahead and write our given. 1.5 moles of sodium chloride. Set up my train tracks. I'm going to put the units of my want are what I circled here. So grams of sodium chloride. And the units of my given are what I'm starting with, what I boxed here, moles of sodium chloride. Then from my molar mass, I'm going to add my numbers. What number goes with my grams from my molar mass? Which one? What number goes with it? 58.44. The big number always goes with my grams, and it's 58.44 grams in how many moles? Because I got it from the periodic table, so it's how many moles? 1. Okay. Then it's on the top. Do I multiply or divide by it? Multiply. So 1.5 times 58.4. You're going to get a big number. I'm going to show you because we'll probably do an IXL thing. It's called significant figures. When we call significant figures, all you need to know about significant figures is the one number with the most decimal points. That's how far you're going to go. So notice this has 1 decimal point. This has 2 decimal points. So you'll always take your answer to 2 decimal points. Okay. If some number has 3 decimal points, you would take it to 3 decimal points. Okay. When you do the IXL, if you guys do that practice, it will ask for that. You just take it to whatever decimal points, the number that has the most decimal points. Okay. You don't need to learn why until you get to college. Okay. Is 87.66 grams. Okay. Questions so far? Doing okay? Yeah? Yes, Jordan.
Is it always going to be 1 mole until
When you put in numbers for a molar mass that you figured out from the periodic table, it's always 1 mole. Okay? For now. For these, yes. Okay? So any number you're going to calculate off the periodic table is always 1 mole. Okay? Good question. All right, let's take it the other way now. Example, let's go from grams to moles. Okay? Let's go the other way. See what happens. All right. All right, so you might have a question that says, how many moles of aluminum are in 59.36 grams of aluminum? So sometimes you might have this many grams. What can I do with it? Okay. So we're going to box our given. What's our given in this one? What is it giving us? 59.36. Good. 59.36 grams of aluminum. What does it want us to figure out? Moles of aluminum. So we're going to circle that. Okay. We're going to calculate our molar mass of the compound or element that we're doing. So it's aluminum. And if you look on the periodic table, aluminum is 26.98 grams per 1 mole. Okay. Now we're going to write our given, 59.36 grams of aluminum. Set up our train tracks. Okay. We're going to write the units that we circled. What do we want? Moles of aluminum. Top, on the bottom, we're going to write the units of our given, grams of aluminum. Then we add our numbers. So remember, the number with our molar mass goes with grams, 26.98 to 1 mole. Okay. Now, this number is on the bottom. What am I going to do with this number? You're going to divide by it. So we're going to take 59.36, divide by 26.98. Notice there's 2 decimal points in both of them, so we're going to give our number 2 decimal points. If you do it out, it's like 2.20001 something. So we will leave it at 2.20. And we're going to add our units. Grams of aluminum cancel with grams of aluminum to leave just moles of aluminum. Okay. Questions on that one? All right, we're going to do one more, and then you guys can practice, okay? One more. Okay, number 2. How many moles of calcium hydroxide are in 185.25 grams of calcium hydroxide. Okay. So first thing, annotate our question. We're going to box our given. What is our given? What is it? What's our given here? 185.25 grams of calcium hydroxide. And what does it want us to find? Good. And moles, okay. And again, our first step is to calculate our molar mass. I'm going to shorten this here, okay. If you get confused as I'm doing this, just ask me, okay. So I have 1 calcium. So calcium is 40.08 plus I have 2 oxygen. So I'm going to do 2 times 16.00 plus I have 2 hydrogen. So 2 times 1.01. And I got these numbers off the periodic table. Will give you 74.1 grams per mole. Okay. Then we're going to write our given, or what we boxed. So we're going to write 185.25 grams of calcium hydroxide. Set up my train tracks. Okay. You're going to put the units of what you want on the top, so what you circled. So I want moles of calcium hydroxide. The units of what I boxed are what I was given. Go on the bottom, so grams calcium hydroxide. Then I'm going to add my numbers. Remember, 74.1 will go always with the grams because it's 74.1 grams in 1 mole of calcium hydroxide. Okay. This number is on the bottom, so what are we going to do with it? Divide. So notice this has 2 decimal points, so we'll take it out to 2 decimal points. And so if you look at that one, it's again 2.500 and some numbers, so we'll leave it at 2 decimal points, 2.50 moles of calcium hydroxide. Okay. Questions? Okay. You have your sheet today. That is your practice. Okay. Same type of questions. Okay. When you are done with that, you can come check your answers. There is no mastery for this one today. If you did not finish your mastery from Wednesday, you should come take that and then work on your practice. All right? Questions? All right. Go ahead and get to work.